Good day, ladies and gents. Welcome back to yet another exciting episode of learning electronics and electrical circuits in the lab at Engineering for VUT. What we've got here in the discussion is multimeters, and we're going to simply show you how to do measurements of voltage. My source of voltages are these little devices, and I wonder who can guess what it is. Aha! Yes, I heard well. It is a battery. I've got two standard batteries here. The one is a PP9 and the other one is a AAA. And who can guess what's the standard voltages associated with these? Aha! This one, very close and often used as 9 volts. And if you look at the side, there, 9 volts, it's written on the side. So that's what we expect, something close to that if it's not flat. And the second one is the small AAA body, those that we find in our TV remotes mostly. And this one, the expected voltage around 1.5 volts. So let's go ahead and measure. To measure, the first question you ask yourself is it AC or DC? Remember, you want to measure a battery. A battery is DC. If I spin the battery, it becomes AC. But who spins a battery, you know? So we would rather like to measure DC. So I look at my range, I look at my scale, I look at the measurements of the devices. Then I go for DC voltage and I select the scale. If I'm going to measure an expected voltage of 1.5 volts, I can put my range on 2 volts. As long as the range is bigger than the range for my battery, I'm good. I can even go for the larger scale, and that is actually the better way of measuring it, because we don't know what the voltage is sometimes. Switch on the device, I measure it, seems to be flat. But here I'm at 500 range. Make the range smaller. There comes an indication. Make the range even smaller, 20 volts. Now I get more digits, and that means more accuracy. Is there something still bigger than? Yes, there is. So this battery is exactly 1,564 volts. And that's not too bad. It means I can still use it. So, can we do the same with the 9 volt battery? Always check your polarity, no? So there is a big plus on the side, a big minus is missing on this product. So if I do it, my meter goes overload, means out of range. No voltage, 0, too big voltage, out of range. Don't do it too often because you may damage your instrument. Now I go to a bigger scale, and what is the procedure? You start with the big voltage and we see if we can find it. It tells me minus 7 volts. How crazy is that? Minus. But there is a positive battery here. I hear you say there in the back. Nice. It is positive. And if I turn it around, negative. Positive, negative. So my polarity is dictated by my probes, which is, by the way, installed correctly. So if I have it like this, it tells me 7 volts. Is that really 7 volts? Let's confirm. So 200 volts is still bigger than 7. Now I get 8.2. 20 volts is also bigger than 7. That I can use. 2 volts. Smaller than 8.7. It will not show. I need to go back. And that, ladies and gentlemen, is how you measure the voltage. Very straightforward. If I want to confirm the polarity of the battery by changing the polarity of my meter, the probes, I can clearly see it becomes minus, it becomes positive. That, ladies and gentlemen, simple measurement of voltage. Thank you.